Section 9.3 is systems of nonlinear equations. And when we solve systems of linear equations, that was finding the intersection point of two lines. So instead of that, we're finding the intersection point of other graphs, such as parabolas, circles, and other different types of graphs. So we're going to be solving these by the graphing method, which means my first step is going to be to isolate y in both of these equations. So let's look at the top one, and I want to get y by itself. So I want to divide everything by -1. So I'm going to call this my y1. And then the bottom equation I want to isolate for y. And then divide by -1. Okay, so I'm going to call that my y2. So I'm going to plug these into my calculator. And the window that I'm using for this is -10 to 10 and -5 to 20. So I found that this window worked the best. You can always kind of play around with the window to try and get the best view of your intersection points. So if you graph it, it should look like this. So my two answers are going to be here and here. So I need to use the intersection command to find those. So if you go to second calc and then intersect, we are going to declare our first curve and press enter, our second curve and press enter. So you're basically just declaring what two graphs you're trying to find the intersection point of. Now the guess, this is significant here because I want to figure out what this one is first, so I want to make sure my guess is closer to that than it is to this one. So as long as it's closer to that first one, and then press enter, then we get the intersection point here. And this just means 0, so my intersection point is 0, 1. Then I need to find the second intersection point. So press intersect. First curve, second curve, those are both the same as we did before. Then the guess needs to be closer to that second intersection point. Again, left and right navigate the current line or curve. Up and down change which graph you're on. So if you make the guess, then you get 4, 17. So I'm going to go back to our problem and make a rough sketch. So there, and that is 4, 17, and 0, 1.